Hi, and welcome to this flipped instructional session. This is for middle school earth science, and today we're going to cover lesson 1.11 and 1.12, which are both about erosion. And I am Mrs. Fessel. In this flipped lesson, we're going to, as I said, talk about erosion, and your goal is to watch this recording before attending the Class Connect session. After you've watched this flipped recording, please look for the flipped follow-up on your schedule. We're going to start off with what is erosion. So in the last lesson, we learned that weathering is the breaking down of rock by wind, water, and any other means. So erosion is going to follow after weathering, and it is the gradual movement of the surface of the land by many of the same things that cause weathering: water, wind, or glaciers. So as I was just talking about, a key concept in this lesson is the difference between erosion and weathering and how they work together. And as I mentioned, weathering is the breaking down of rock, which will come first, and then erosion is the movement of that rock. So they work together and come one after another. Now we're going to go into a few different types of erosion. First, we have water erosion. Moving water is one of the biggest things that causes erosion. Running water, such as streams and rivers, can pick up and carry soil and small rock particles. As you may have seen, sand, dirt, rocks moving downstream in a river. So what would cause more erosion, fast or slow moving water? The answer would be fast-moving water because it has more energy, it has more momentum, and it's easier for it to pick up and move those particles. Here's the answer again. Fast-moving water can cause more erosion because the faster the water is moving, the more energy it has and the larger particles it can carry. Very large, fast-moving streams, especially if they're flooding, can move even boulders. Fast-moving water can also carry more material than slow-moving water because, again, it has more energy. So we have a third vocabulary word that works along with weathering and erosion, and that is deposition. So deposition is the process in which rock and soil move from water, wind, or ice onto the land. So basically the particles are being dropped off or deposited, which is deposit is the base word here, which is where it comes from. So one way to remember this is wed. If we think about weathering, erosion, and then deposition. That's the order they go in. First, weathering breaks down the rock, RW. Erosion moves the rock, RE, and deposition breaks down the rock. Drops the rock in a new spot, D. So WED, weathering, erosion, deposition, might help you to remember the order that these three terms occur in. So erosion and deposition is one thing that causes rivers to be windy. We sometimes call this meandering. So over time, rivers, even ones that start straight, will oftentimes form this S curve that we see happening here. Why is that? That's because fast-moving water on the outside edge, right here, if you think about it, water gets moving faster out here to try to keep up with the water on the inside of the curve. So this fast-moving water erodes the rock and dirt away from here. The opposite happens on these inner curves right here. On the inner curves, the water slows down. As the water slows down, we talked about slow-moving water can carry less particles. It actually drops some of the particles that it's carrying, and they get deposited, which is our deposition. So on the inside of the curve right here, we have deposition happening. Rock and soil get dropped off because the water slows down. On the outside of the curve, right here, the water gets moving faster. It can carry more rocks, soil, and dirt, and it picks it up and causes erosion. So even rivers that start out straight oftentimes will become meandering because of erosion and deposition. So moving water can also create canyons. Many scientists think this is how the Grand Canyon formed. So running water eroded the sides of this canyon and created a V-shaped valley as the rock got moved away. Another way water can cause erosion is by waves. If you've ever been to the beach, you can see that first of all, the waves can just pick up the sand and carry it away. That's erosion, but the waves can actually move pieces of rock away too, as the rock gets weathered down, and then erosion moves those rock particles away. We also mentioned that glaciers can cause erosion. It causes erosion through ice. Glaciers can actually move entire boulders because the glaciers are large moving masses of ice and snow on land. Glaciers actually are, even though they look still, are moving. These glaciers are flowing this way as they flow down. So ice erosion would happen down the sides of these mountains. Gravity is what pulls the glacier slowly down mountains and across the land. As the glaciers move, they can actually pick up rocks and soil and carry them for long distances. Whereas water creates more V-shaped valleys, usually glaciers are going to create these larger U-shaped valleys that we see right here. Next, which can often be seen in deserts, is wind erosion. Wind can pick up small pieces of rock and sand and carry them for thousands of miles. As I said, this occurs mostly in deserts and on plains. And a crazy fact, scientists have actually found dust from African deserts all the way on the other side of the earth in Hawaii. So when wind erosion happens, it can often create arches along with strange shaped rocks. All right, so a little bit more about how wind erodes. The particles carried by wind can actually act as sandpaper and wear away at wood, rock, and even metal. So wind can blow in all directions and it can create these strange shaped rocks, such as the one we see in this picture here. All right, so our last term is called mass wasting, which is kind of a funny word. But this is caused by gravity. Gravity causes things to move downhill towards the earth. So things like landslides and mudslides involve the movement of large amounts of rock and soil down mountainsides or hillsides. And this is called mass wasting because a large amount of mass moves downwards. So you can see it in this triangle right here that there was a mudslide because it's different than the rock around it. So when this happens, many tons of rock may move downhill at close to 96 kilometers or 60 miles per hour. It can even trigger an earthquake or volcano, be triggered by an earthquake or volcanic eruption. Here's just some example of landslides, mudslides, and simply the slow creep of sand and dirt downhill by gravity. So creep, as I mentioned in the last slide, is just kind of slowly dirt, rock, and sand slipping down a hillside over many years, sometimes from temperature, sometimes from water. Here's an avalanche, which is similar to a landslide or mudslide, but simply with ice and snow instead of rock. All right, so what can be done to prevent erosion? So some things is that people, when they farm, will use terraces or plow fields in this pattern to stop the water from moving downhill. All right. So your next steps are to look for the flipped follow-up sessions on your Class Connect schedule, attend this live session to carry the topic into further practice, and attend a Help Lab session for extra support. As always, I hope you have fun learning. Have a great day. Thank you. Bye.